Hello students, my name is Shayan Mitra, faculty member of Department of Electronics and Engineering, Communication Engineering of Greater Kolkata College of Engineering and Management, JIN School. Today's topic is process organization. So let's go to the slides. Embedded System ECE 703A is the code and this is the lecture 5. So let's start with the slides. Contents that I am going to discuss for this lecture and for the next lecture we are going to describe this. For the next 3 consecutive lectures I am going to discuss these contents. First one is structural units in a processor selection for an embedded system, memory device, memory selection for an embedded system, allocation of memory to program segments and blocks and memory map of a system, direct memory access, interfacing processor, memories and input-output device. In this lecture I am going to discuss structural units in a processor selection for an embedded system and memory device. These are the 3 topics. So let's start with the lecture. So first objective is to understand the structural units in a processor. So let's start. So first structural unit that we have here is MAR, M-A-R, Memory Address Register, and what its functions are. It holds addresses of byte/word to be fetched from external memory. Processor issues the address of instruction or data to MAR or MAR before it initiates fetch cycle. What it means? It means first point, in case of memory address register, it holds address of byte or in form of byte or word to be fetched from external memory. So in memory address register, it holds the address which only fetched by the external memory. External memory means the secondary memory. Secondary memory extract or fetch the address that is held by memory address register. This is the first. It means the external memory, the address that is fetched by external memory used to be stored in memory address register. Second point, processor issues the address of instruction or data to MAR before it initiates fetch cycle. It means the processor, before initiating the fetch cycle, it fetch, as we have already known that when we are discussing the architecture of a processor, what we know that a processor fetch the memory, decode that memory, and fetch the programming instruction, then decode it, and after that execute that program instruction on the data that it fetched from the data memory. So the first step of a processor is to fetch the memory. Now as the processor initiates its fetching cycle, it means a cycle in which it fetch the data, any kind of data. It's an address, it's a memory, it's a program instruction, or the data. So this is fetch cycle. It means fetch cycle. Within the cycle it fetches the data. Now when it first started the fetching cycle, it means it will start the fetching of programming instruction. It issues the address of instruction or data to memory address register. It means in memory address register it holds the address of the programming instruction that the processor needs to fetch. That's why it issues the address of instruction or data to memory address register. Next is memory data register. Now what is the function of memory data register? Memory data register holds a byte/word in a form of, it's a 8-bit information. It holds a 8-bit on basically 8-bit a byte/word fetched. Memory data register holds a byte from an external memory or input-output address. It means it simply holds a information or data that is fetched from an external memory or input-output address. What it means? It means in case of memory address register, it holds the address, and in case of memory data register, it holds the data that has been fetched from an external memory. A data that has been fetched from external memory or input output address, that data has been saved in memory data register. In case of memory address register, it holds the address of the instruction that is fetched by the external memory, and in case of memory data register, it holds the data that has been fetched from an external memory or input output address. Now the structure in the structural unit, there is other four important factor here. Is it system buses? First one is internal bus. Internally, in what the function of internal bus? We have already seen in our architecture that there is a single pipeline. Above it there is microprocessor, and below that specific line there is a DSP and other factors are there. That is the internal bus. That has been drawn in a picture where basically it's a 3D format. So in case of internal bus, internal bus internally connects all the structural units inside the processor. So and according to that 8-bit, 48, 64, it depends upon the width of if the width of the internal bus is 8 bits, it means it is it's a less faster. If we have a 64-bit, it means the internal bus can process or can communicate with different unit of processor faster. If it has a greater width, it will communicate faster. That's the point. And it internally connects all the structural units inside the processor. In the structural units of inside of the processor is we already have the different kind of capacitor. There are many different things, controller, processor, software. There are different kind of functions. We have already discussed all those things. Now in case of address bus is external bus that carries address from memory address register to memory, as well as to input output device and other units of a system. Through address bus is an external bus that carries the address from memory address register to memory, as well as to input output device and other units of the system. It only carries the address. In case of data bus, is external bus that carries, during read and write operation, the bytes for instruction/data from to an address determined by MAR. From memory address register, the address of the programming instruction has been fetched by the processor. After that, through the memory data register, what the memory data register do? Memory data register fetch the external memory data. So it fetch the byte fetch the data to be sent from or to an external memory or / input output device. So data bus, what it does, it basically, as according to the instruction or determined by the MAR or the programming instruction, it carries the carries the read write operation. Read write operation means in case of the bytes from it will come from the external memory to the address register or the instructional cache, or it will goes away from the instructional cache, or the data that has been fetched from the data memory into the processor where the data has been used to process or has been processed, and again it will be sent it back. So all these operation, all the data is communicated within the different structural unit through the data bus. Now the control bus. It's an external set of signals to carry out control signal to processor, memory and /device. Basically, control bus is the bus through which all the control signals that are sent to the different structural unit of the processor. Through the control bus, all the control signals, basically what they do, it basically instruct each and every structural unit to do their job or do their work. So each different control signal control the functionalities of different structural units of a processor. Let's go to the next slide. This is the first part. Yes. Next the bus interface unit. It's an interface unit between processor internal units and external buses. This is the bus. In case of this way, we need to remember this name. Bus interface unit is the interface unit between the processor internal units and the external buses. Next is instruction register. This is an important part. Instruction register sequentially takes instruction codes or opcode, machine code, to execution unit of a processor. It means in instruction, these are specifically register. What a register do? A register holds a data. That's the basic function. Now the instruction register sequentially takes instruction code. This is specifically instruction register to instruction codes to execution unit of processor. Code to execution. So instruction code will be fetched by the processor from the instruction register. From the instruction register, processor fetch the execution codes or the opcode. It will goes to the execution unit of the processor, and according to that the processor determine its next job. Third is instruction decoder. Decodes the instruction received at the IR and passes it to the processor. It means it is between the central. It is a part of a. It basically is in between the instruction register and the processor's control unit. It passes into the processor of the control unit. So instruction decoder is basically fetch the data that has been stored in the instruction register. It decode all those codes and it passes to the processor control unit, and that processor control unit, according to the decoded data, according to decoded instruction, practically it dictate the other unit to act accordingly. If it have to fetch a data for the data memory, or it have to supply or you have to send a control signal to a structural unit of any structural unit of the embedded system design of the processor, it has happened by the control unit according to the decoded instruction set. Next is the control unit. Controls all the bus activities and unit function needed for processing. It is self-explanatory. AR is application register set of on-chip register. That's the important factor. It's an application register set. There is a set of on-chip register used during processing of instruction of an application program. It's used during the process when we are decoding an instruction, processing an instruction. This application register set is used. It means during the sequential decoding of a set of instruction, for a very few moments, the instruction, those who are not fetching, those who are in the queue, are used to stored in the application register set. It is used for the first purpose. As if that the first code is, if you suppose that we are processing the first code, so the second, third and fourth third, fourth application set, programming set or the instruction set stored in the application register. Next is the arithmetic logic unit. We already know what the function of arithmetic logic unit. This unit to execute arithmetic logical instruction according to the current instruction present at IO. The current instruction that is present according to the present instruction in the IR, the arithmetic logic unit operates. It does its mathematical calculation differently. And the program counter, this is PC. That is, it's a very important factor also. It generates an instruction cycle by sending the address defined by it to memory through the memory address register. What its function is? Generates an instruction cycle by sending the address defined by it to memory through the memory address register. Auto increments as the instruction are fetched regularly and sequentially, called as instruction pointer in 8086 processor. So these are the okay, let's go to the next slide. Stack pointer for an address which correspond to a stack top in a memory. It means stack pointer points to the top of the stack practically. When that stack pointer is instructing or indicating the address of the data that's stored in the top of the stack. As that data goes, the next data which pop up on the top shelf, the stack pointer will be indicating the address of that data. So that is the function of a stack pointer. It basically used in case of a register which have data sequentially arranged, and that stack pointer usually indicating the address of that data. Instruction queue of instructions, so that queue of instructions basically, so that instruction register doesn't have to wait for next instruction. Does not have to wait for the next instruction. Queue of instruction is basically, it means it basically also a sequential process that each and every instruction is arranged according to the queue. As the instruction is processed and goes to the control unit through the processor or the control unit section of the processor, the next instruction is automatically pushed towards the first shelf. Suppose a register which has a fourth shelf. Now the first instruction has been fetched, so the second instruction will get to the first, the third instruction will get to the second, the fourth instruction will get to the third, and another instruction, that is which when the fourth segment of the register is emptied, the another instruction will sequentially fill up the gap. Next is the prefetch control unit. This unit controls the fetching of data into input I and D caches in advance from memory units. It means we have four. In case of microprocessor, we have number of caches. So prefetch control unit controls the fetching of data into I and D caches in advance from memory units. It means it fetches it before the time, before it is needed. It has been already fetched all it's already fetched the data into the I and D caches. Basically, as you have already know, if we increase the instruction cache within the CPU, the performance of the processor will go higher, because it doesn't have to fetch a data from the program memory each and every time if it requires an instruction cache. If we have a higher number of cache, it means that processor, the fetching cycle, the fetching time will reduce, so the performance of a processor will increase. That's why it has been said that improve performance by fetching instruction and data in advance for processing. Cache, instruction cache. What is instruction cache? Sequentially stores like instruction queue instruction in first order mode. Lets the processor execute instruction at greater speed using prefetch control unit. Next is the cache, that what I have already described. Cache data cache. It means stores prefetch data from external memory, stores both key and value together at a location. Also stores write through data when configured. Write through data after configuration also stores those data. Branch target cache. Facilitate ready availability of the next instruction set when a branch instruction like jump, loop, call is encountered. It basically the next instruction set of the jump, loop, call. If jump, loop or call instruction has been encountered, the next instruction set is readily available in the branch target cache. Suppose we have to perform a different operation, so that different operation has been stored in the branch target cache after the first operation. Next is memory management unit. Manages the memories such that instruction and data are readily available for processing. System register set of register used while processing the instruction of the supervisory system program. Set of register used while processing the instruction of the supervisory system. If it is required, if the data or the instruction of supervisory system program needs to be processed, then the system register set will be come in handy. So let's go to the next slide. Next is a floating point processing set. Separate unit for ALU for floating point processing, which is essential in processing mathematical function fast in microprocessor DSP. A floating processing unit is nothing but to if I have the mathematical operation which include floating point. That's where the floating point processing set will be coming useful. Floating point register set. Register set dedicated for storing floating point numbers in a standard format used by FLPU for its data and stack. Multiply and accumulate unit. Units for multiplying coefficients of a series and accumulating these during computation. It's a computation unit practically. Atomic operation unit. It lets, atomic means singularity. That's how you have to understand that. Atomic means singularity. It lets a user compiler instructions when broken into a number of processor instruction called atomic operation. It lets the user / compiler instructions when broken into a number of processor instruction called atomic operation finish before an interrupt of a process occurs. It basically, suppose there is a program that has been running. Now suppose during that program, suppose a program that need 15 minutes. Suppose at the 8th minute there is a interrupt. That has been called that you have to perform a different segment of processing. So those processing units, those are already processed. Those data will be stored in the atomic operation. It means the atomic version. It means it's a small part of a whole program will be stored in the atomic operation. That's what it has been said. It lets a user/compiler instruction when broken into a number of processor instruction called atomic operation finish before an interrupt of a process occurs. It prevents problems from arising out of shared data between various routines and tasks. It means it create or it will maintain the continuity or integrity of a specific program instruction. A specific program instruction's integrity will be maintained by the atomic operation unit. Suppose the programming instruction that has been performed within the 8 minutes, all those data, all these atomic data, singular data will be stored in the atomic operation to maintain the continuity. So let's go to the next slide. Organization of various structural units of a processor. Those that we have discussed all this. So these are the internal buses. These are the instruction how we have these are the architecture of all the instruction set of the instruction registers. Okay, instruction cache, data cache, PFSU, MMU, PC, memory address register, memory data register. It is the arithmetic logic unit, fetch, AOU advanced processing units. This is the bus, address bus, data bus, and control. This is the architecture of this. So let's go to the next slide. Features in most processors. First, instruction cycle time. Instruction cycle time is the time taken by a processor to execute a simple instruction. 1 microsecond for 8051, 1.6 nanosecond for MPC 604. It means a time taken by a processor to execute a simple instruction. To execute a simple instruction, a processor usually take for 8051 1 microsecond or 1.6 nanosecond for MPC 604. System designer uses as an indicator to match the processor speed with application. That's the basic target. Internal bus width. ALU gets inputs through internal buses. 32-bit bus to facilitate the availability of arithmetic operation on a 32-bit operands in a single cycle. 32-bit bus are necessity for single processing and control system instruction. If we have a 32-bit bus, we can operate with 32-bit data or 32-bit operands in a single cycle. Each cycle there will be 32-bit operands. If we have a 64-bit, then in a single cycle there will be 64-bit operand or data or program instruction. This is a program counter. Okay. Number of program counter bits decide maximum possible size of physical memory that can be accessed by the processor. Reset value tells the designer the initial program address from where the program runs on a system reset power. Reset value will tell the designer that initial program when we button up when we switch on when we on the power switch of a computer, the reset value tells the designer the initial program address from where the program runs on a system. This is the first step. In case of number of program counter bits, this is the maximum possible size of physical memory. That's what it is. According to the program counter size, the maximum physical memory will be decide or can be accessed by the processor. Both are same thing. Let's go to the next slide. Processor selection. It's an important factor. Processor specific feature should operate at higher clock speed for processing more instruction per second. If you have a higher clock speed per second, there will be more processing. It means the processor will be faster. High computing performance when there exist pipeline, a superscale architecture, preface cache unit, caches, register files, MMU and RISC architecture. Register Windows provides fast context switching in a multitasking system. Power efficient embedded system requires a processor that has auto shutdown feature for its units and programmability from the disabling use of caches when the processing need for a function or instruction set is not constrained by limit or execution time. Uses stop, sleep and wait instruction. Also requires special cache design. So if we want to have a complex program, we also need to have a complex hardware. That's why it will help each other. Let's go to the next slide. processor specific feature. Burst mode access. Burst mode access external memory fast, reads fast and writes fast. Burst mode access external memory is fast, reads and fast and writes fast. Atomic operation we already said, provides hardware solution to shared data problem when designing embedded software. Else special programming skill and efforts are to be made when sharing the variables among the multiple tasks. Big Endian MSB to lowest address, or Little Endian is LSB to lowest address. MSB and LSB. Energy, and so always have to be energy efficient. That's one of the most important factors. Case studies. Case 1. System in which processor instruction cycle time is 1 microsecond and on-chip device memory can suffice. Automatic chocolate vending machine, robots, data acquisition system. The system in which processor instruction cycle is 1 microsecond and on-chip device and memory can suffice. Lesser speed, automatic chocolate vending machine, robots, data acquisition system. Case 2. System in which processor instruction cycle time is 10 to 40 nanosecond and on-chip devices and memory do not suffice and medium processor performance required. 2 Mbps router, image processing, voice data acquisition, voice compression, etc. Case 3. Systems in which instruction cycle time is 5 to 10 nanoseconds require a high MIPS and MLFS performance needed. Multi-port 100 Mbps network transceiver, fast 100 Mbps switches, router. Case 4. System in which instruction cycle time of even 1 nanosecond does not suffice and multiprocessor system is required along with use of floating point and memory address counter unit, voice processing, video processing, real-time audio video processing. Okay, so this is all the thing that we have studied. From the next lecture we'll be studying memory organization. Thank you.